Let's do example 3. Go ahead and give an asterisk to it, and if you have a highlighter, you can highlight it as well. Use the converse of the isosceles triangle theorem. What are the lengths of all 3 sides of the triangle? Well, we may have to get a little creative here. They tell us that this angle is equal to that angle. And if that is true, then this side is equal to this side. To figure out what the side equals, we can make an equation. And that equation will be x plus 20 is equal to 8x over 3 because the 2 sides are equal. Now we have to solve for x, and we're going to have to be problem solvers on this because this is a little tricky. Whenever you have a fraction in an equation, you can get rid of that fraction by multiplying by the denominator. So what is the denominator of this fraction 8/3? Yeah, 3, because the denominator is the bottom number. So we're going to multiply this side times 3, and we have to multiply the other side times 3 to undo the denominator. So that cancels the denominators. And on this side, we will distribute. So 3 times x is 3x. And what's 3 times 20? Good, 60. And those 3's canceled, so we're just left with 8x. It is a much simpler equation to work with now. I know that usually we like our x's on the left, but since we have variables on both sides, I'm going to subtract 3x. Just because if I subtracted 8x, that would leave me with 0 on that side, which is fine, but this is easier, so trust me. Subtract 3x from both sides. The 3x cancels on that side, leaving us with just 60, and 8x minus 3x is 5x. The next step is to divide. We'll divide by 5. This cancels. 60 divided by 5. What's 60 divided by 5? Good, it's 12. So x is equal to 12. That is not the answer. The question asked, what are the lengths of all 3 sides of the triangle? So to figure that out, I have to take the x and I have to plug it in to, oh, sorry about that. We have to plug that into this x. And you can plug it into the other x's as well, but let's just start with this. So 12 plus 20. Well, I'm going to label this 1. So 1 is 12 plus 20. That equals 32. And then side 2, so I'll call this side 2. It better equal 32 also because they should be equal, but we'll plug in 12 to x. 8 times 12, do some mental math, 80 is 96. 96 divided by 3, oh thank goodness, it's 32. Awesome. And for the third side is over here. 6 times x, which is 12, minus 12. That's going to be 72 minus 12, which equals 60. And that is it. You found all 3 sides of the triangle. Get ready. For this try it, I would like you to work with your partner and figure out what the value of x is in part A, and what are the lengths of all 3 sides in part B. We have another theorem. So go ahead and asterisk that, and if you have a highlighter, highlight it. If a line or line segment bisects, that means cut in half, the vertex angle of an isosceles triangle, then it is also the perpendicular bisector of the opposite side. So here you can see that this angle is bisected. It's cut in half. So instead of being the angle 80, it's now 40 and 40. Then this line that bisects it also bisects this side of the triangle into two equal parts. And that is what this theorem is saying. If AB is congruent to BC, right? So if these sides are congruent, then it's isosceles. And the measures of ABD, that's this angle, and CBD, this angle, are equal, then BD bisects AC and BD. And AD is congruent to DC. For example 4, we will use perpendicular bisectors to solve problems. So if you have a highlighter, you can highlight that. We're using the perpendicular bisector. If you don't have a highlighter, just draw an asterisk. A prefabricated house is delivered to a foundation in two symmetric halves that are assembled on site. Along the planned route to the site, the truck must pass under a bridge that has a clearance height of 17 feet. Should the trucker plan a different route for delivering the house? Explain. So basically what we're being asked here is, will the house fit under the bridge? And the bridge has a clearance height of 17 feet. Well, I think you also have to think about how tall the truck is. Looking at this house, it's already 10 feet right here on this side. And we need to know this height here. So how could we figure that out? Well, using the perpendicular bisector theorem for isosceles triangles, we can say that this side and this side are equal in measure, and if we have a right triangle right here, we can use the Pythagorean theorem to figure out the height of that triangle. So let's see. If this side over here is 28, like all the way across is 28, then each of these pieces has to be 14. How did I get 14? Yeah, half of 28. So I'm just going to draw this triangle out here on the side. And I'm going to label it 14. This is a right triangle, and I'm going to label this 16 feet. We want to know this side. So if you remember the Pythagorean theorem, awesome. If not, I'll review it for you really quick. This is side A, so A equals 14. The side B we don't know, and the side C is 16. Does anyone remember the Pythagorean theorem? If you were thinking A squared plus B squared equals C squared, awesome on you. We have to solve for side B. So let's plug in our numbers. We have 14 for A. So 14 squared plus B squared, we don't know B. C is 16, so 16 squared. Now we have to solve for B. To do that, we're going to square each of these. So let's see. If you have your calculator, you can do it with me. 14 squared is 196. That's 14 times 14. 16 squared, 16 times 16 is 256. Solving for b, I'm going to subtract 196 from 256. That cancels this. This will be 0. This will be 6. So b squared equals 60. And then I have to take the square root of both sides. So the square root of b squared and the square root of 60. The square root of b squared is b. The square root of 60 is between 7 and 8 because 7 squared is 49. 8 squared is 64. So it'll be closer to 8, but less than 8. So I'm going to do the square root function in my calculator, and I get approximately 7.75 feet. There is no way that that truck is going to be able to make it under the bridge, because unless they take the top off, but they didn't say that. They said that they cut it's cut down the center of the house. They don't assemble the top separately. So the height of the house plus the height of the roof, the house is 10 feet. The roof is 7.75 feet approximately. If I add those together, I'm getting 17.75 feet. The truck needs to find another route. Okay, when you're ready, turn your page. I would like you to try these try-it problems with your partner. So what is the measure of RSQ and what is PR? And you can use the figure to your right to answer those questions. We'll come around and help you. For example 6, put an asterisk or highlight it. Find angle measures in isosceles and equilateral triangles. If the measure of CBD is 130 degrees, what is the measure of BAD? Well, what can we do? How can we problem solve this? The first thing that I'm noticing is that ABC is an equilateral triangle. And in an equilateral triangle, all of the angles are equivalent in measure, which means that every single angle has to be 60, because what is 60 times 3? Yeah, 180. So every equilateral triangle has every angle equal to 60 degrees. Well, if CBD, this angle here, is 130 degrees, then we need to subtract. So we'll do 130 degrees minus 60 degrees. That gives us 70 degrees. So that means that this angle here is 70 degrees. But that's not the question, right? They're asking, what is this angle up here, BAD? So we need to keep working this out. The triangle BAD is isosceles because there are two sides equal in measure. So we can say that BAD, this angle here that we're looking for, is the same as this angle over here, BDA. And if that's true, then what we need to do is figure out those two angles. They're equal in measure. So I would do 180 degrees minus 70 degrees, which is 110 degrees. And then if those two angles are equal, then we're just going to divide 110 by 2. So 110 divided by 2, that equals 55 degrees. So the measure of angle BAD is equal to 55 degrees. Right here. On part B, what is the measure of angle U? So I'm trying to figure that one out. What are you noticing? Okay, so we have an isosceles. We have two isosceles triangles put together. We just need to fill in all of the pieces to figure out the missing piece. And I'm going to start with this 72. So if that's 72, then these two angles here have to be equal in measure. So we'll take 180 minus 72, and we get 108 degrees. Then we're going to divide 108 by 2, and that gives us 54 degrees. So that means that angle T and angle V equal 54 degrees. So I'll write that in, 54, 54. But I'm still trying to figure out angle U. So angle V, or this UVT right here, I can figure out because it makes a straight line with 54. All right, and if it makes a straight line, then this measure of that angle has to be 180 minus 54, which is 126. So this is 126. And now we just need to do the isosceles part, right? Because this angle over there and the angle that's with the T and the angle that's with the U, those are going to be equal. So I'm going to do 126 degrees subtracted from 180 degrees is 54 degrees. And then we're going to divide 54 by 2, and that would equal 27 degrees. So the measure of angle U is 27 degrees, and up here is 27 degrees. So we'll write the measure of angle U to answer the question is equal to 27 degrees. And it's just a little puzzle. So before we leave today, I want you to ask one question. So what is a question that you have about lesson 4.2? So before we finish the notes, answer that, and then you can start your assignment.